Hello, everyone. Welcome to my office hours. This is a question that is, I've had this question from everybody looking for how to solve. This is one of the homework questions. So I want us to do it here. I just want to let you know that my laptop doesn't have installed calculator yet, but I will try and still do it until I install a calculator. All right, so given this function, 5x minus 3 parentheses squared multiplied by 1 minus x, forgive me for the scribble, to power 4 all cubed equal to the function y, find y prime. So the first thing I want to do if I am find y prime is I like to rewrite. So I'm going to rewrite this question. Y is equal to u over v, where I like my u to be numerator. So, I'm sorry, this is not, so I'm going to take that off. Let me cancel that. So y is equal to u multiplied by v because it's product. So since it's product, I'm going to use the product rule of derivative. And so y prime is bring down u multiplied by the derivative of v plus bring down v multiplied by the derivative of u. So I want my u to be the first expression. The first expression is a chain rule. So we talked about chain rule. So we're going to do the derivative by chain rule. So my u is equal to 5x minus 3 all parentheses squared. And then I quickly want to find my u primes on the same line. So u prime is equal to, well, using the chain rule, I have 2 multiplied by bring down everything inside the parentheses, 5x minus 3. Use power rule for the exponent. So 2 minus 1 is 1. Then, so now I have everything about u. I'm going to circulate. So this is my u and u prime. And so here I am going to find my v and v prime. All right, so my v is the second section 1 minus x to power 4 all raised to power 3. Then I'm going to find my u v prime. I want you to know that v is a function inside a function where the inside is g of x and the outside is g of x and to power 3. So I'm going to find the derivative by chain rule again. So by chain rule, bring down the exponent, which is 3. Now bring down the inside function, which is at g of x. Then apply power rule. 3 minus 1 is 2. Then multiply by the derivative of g of x, which is x minus 1 minus x to the 4th, which is the same as minus 4x to power 3. And then I can simplify. So let me simplify my v prime. And so my v prime is equal to minus this multiply this, 3 and negative 4 is going to be negative 12. And then bring down this x cubed. Then bring down whatever remains here, 1 minus x to the 4th all squared. And now I am going to be ready to, I think I'm already simplified my v. So very well, so I am going to circulate. All right, so if I look at my u prime, I can also simplify this u prime to look easier. So that is 10x minus 15. All right, so now I'm about to substitute all my answers in here. So actually in here, and so my u prime, y prime, which is the derivative, is now, I want you to remember that my u is equal to 5x minus 3 squared. So I'll bring down 5x minus 3 squared, multiply by the derivative of v. Derivative of v is right here. So minus 12 x cubed, a bigger parenthesis outside, then bring this down. 1 minus x to power 4, then squared. And then the outer parenthesis. All right, so outer parenthesis here. But I want us to remember that is plus. Plus. So bring down this plus. Plus. What is v? That is my v. So I'm going to bring down v. 1 minus 4. 1 minus x to the 4th, all raised to power 3. And then notice that my u prime is 10x minus 15. So I am going to multiply by my u prime, 10x minus 15, 10x minus 15. So I'm going to simplify as much as I can, and I don't have to finish all the simplification. So I want you to notice that this is a combination of product rule and chain rule. A combination of product rule and chain rule. So I'm about to simplify. I want to see if there's anything common to here and here. Yes, there is. This is common. So I know that I will take 1 minus x to the 4th, 1 minus x to the 4th, and so only 1 minus x to the 4th squared is what I'm going to take out. 1 minus x to the 4th, and then I'm going to square it. So I have taken this out. So this one is out of the parentheses right now. I want to see if there's any other thing I can take out. I don't think so. So for now, I am going to bring down this. So I have, or I can just start from here, minus 12x cubed. And then I'll also multiply by 5x minus 3 all squared. Okay. I want us to notice that this are still inside the parentheses. And then I'll put plus, and I'll bring down whatever remains here. Remember that 1 minus x to the 4th to power 1 is remaining. So I am going to have 1 minus x to the 4th to power 1. Bring down 10x minus 15. All right, so there is more simplification to do because I can open this parent, but I don't have to. I can just leave this like this because I don't want to involve myself into a lot of. But at least so far so good. I know that it is finding the derivative of a product rule, also applying chain rule. So I'm going to stop here. Your answer may not be exactly the same thing as this, but the work shows that you have done some algebra, some simplification, and that you actually know it is product rule applying chain rule. All right. So this is question. This is a question in section. I think it is 1.7, section 1.7. One of the homework questions. This is one of the homework questions in section 1.7. Section 1.7. All right. So this question is trying to tell us that we can be given both chain rule and product rule at the same time. And so we need to know all the forms of derivatives that we learned from Math 130. Okay, let's get to another question. This question, the next question is from section 2.2. Section 2.2. All right, let's write this question here. This question said, find the equation of the tangent line to the curve. And this curve is y equal to natural log of x all to power 3 at x equal to 11. So this question is from 2.2. A student sent me this question, so I decided to do it here. Okay, so actually at this point x is equal to, the point x is equal to 11. I don't know the value of y. So the first thing I have to do is to find the value of y given the value of x. So the first thing I want to find is the value of y. I want to rewrite y as f of 11, which means substitute 11 in this function so I can find the point y. So I did natural log of 11 raised to power 3. And if I put this in my calculator, I have something like approximately to 2 decimal places, 13.79 to 2 decimal places. I'm going to use 2 decimal places. Therefore, now I know that y is 13.79. All right, so I have the points. Now, I remember that the reason why I got this point is because I know if I'm looking for equation of a tangent line, I need to use the point slope formula. So I have y minus y1 is equal to slope into x minus x1. It is because I don't know my y1 that I did this. So now I have y1. This is y1. And I know that this is my x1 that is given to me. But the next thing is I don't know the slope. But one thing I do know is that the slope is the same thing as y prime evaluated at x equal to 11. So I'm about to find the slope right now. But the slope is find the derivative of y evaluated at x equal to 11. So that's what I'm going to do right now. So I want to find the derivative of natural log of x raised to power 3. But also remember that the derivative, if y is equal to natural log of x, from Math 130, we know that y prime is equal to 1 over absolute value of x. So now we remember this. We want to apply this in finding the derivative of this function. So given that y is equal to natural log of x all to power 3, I already see that this is function inside a function. So I'm going to use chain rule. And this means that y prime is applying chain rule 3 into natural log of x all to power 2. That means 3 minus 1 is 2. Multiplied by the derivative of the inner function. The inner function is natural log of x. And I already know that natural log of x is 1 over absolute value of x. Then I'm going to simplify. I'm going to assume that absolute value of x here is going to be positive, so I'll just leave the absolute value alone. So now I want to, this is my derivative. I will quickly try to evaluate my derivative at x equal to 11. And this means, this implies that I will rewrite 3 into natural log of x, and x is 11, natural log of 11 all squared multiplied by 1 over 11. If I simplify this, I will have approximately 1.57. Approximately, from my calculator, I have 1.57. All right, so now I have the slope. So this is the same as slope. So now I have slope. I can now plug in the slope. See, I have y1. Y1 is already here. I have x1, it is 11. I have slope. So I want to find the equation of the tangent line. So that equation is y minus, and my y1 is 13.79 is equal to the slope. Slope is 1.57 parenthesis x minus x1. x1 is 11. This is my equation. Now I can simplify. By the time I finish simplifying this equation, I will have the actual equation. The final equation will be, I'm gonna write it here with another column. So I'm gonna write it here. So the final equation will give me y right here. Y is equal to 1.57 x minus 3.46 minus 3.46. Don't have enough space to write all this here, but this will be my approximate final answer, 0.46. So that will be my approximate final answer. Hope I didn't have a lot of all right, so whenever you're told to find the equation of a tangent line, you make sure you have 2 points. You have a point. If you're given only x, the point x, first find the value of y, because you want a complete point where you have x and y. So that's what I did. I found the equation of, I found the point y by substituting the point x in the original equation. Now that I have this point, I know I'm going to use the point slope formula of the equation of a line. And this point, 11, 13.75, is this x1, y1, and x1. And the next thing I want to do is find the slope of the tangent line. The slope of the tangent line is the derivative of that function. I found the derivative of that function, the slope of the tangent line, that is it here. Then evaluate 11, which is x. So I evaluated 11. And after I did evaluate 11, I have that the slope of the tangent line is 1.57. Now I'll substitute in the point slope formula. I already have x and y, and then this is the slope, which is the derivative. If I simplify this equation, I will have the equation of the tangent line to that curve. In class, I will show you how to find the equation using the calculator. By the way, let me show you how to do it without. Now, to find the equation, to find the slope of the tangent line with your calculator. Wait, your calc. I don't have a calculator. Just want your calc. Go to math. Math. Arrow to n derivative. And then bring down the function, and it's going to ask you what is the function. So the function is, you already want to put this equation in y1, so y1 comma in terms of x comma, and then the number given to you 11, that gives you the slope of the tangent line. We'll do it in class though. And when you have the slope of the tangent line and you have found the point, then you plug in the slope and the point in the point slope formula and get the equation of the tangent line.